Hi everyone, welcome to Physics with Ben. Don't forget to subscribe, like, comment and share this video to those that need it. I want to teach us in this video how to find the density and the volume of irregular objects. For example, the object I'm holding in my hand, this stone. This is a perfect example of an irregular object. In this video, I also want to teach us how to find the density of water and the mass of water. How do you go about it? Very, very simple. So without wasting more time, let us go straight to the business of the day. Recall that the equation to find the density of object is given as rho is equals to mass all over volume. Yeah. Rho is equals to mass all over volume. We can call this our equation number 1. So, when we make mass the subject of the formula, we have density times volume, and that is equation number 2. So, we also find that the volume is equals to mass over density. We call it equation number 3. So, we are going to make use of these 3 equations in this video that you are currently watching. So first up, we want to find the mass of this stone. The apparatus needed for this experiment, you need a weighing balance. This is a digital weighing balance in the lab here. You need a measuring cylinder. You need a quantity of water. Now, before I proceed, I want to educate us on how to use this measuring cylinder. This measuring cylinder is calibrated from 50 to 200 centimeter cube. From 50 to 100, you have 10 small calibrations. So it means 100 divided by 10 will give you the value of each calibration. That is, each calibration here is 10 cm cube. Are we good? So, first up, we are going to on our digital weighing balance, and we are going to put it in grams. So the weighing balance is on. We are going to place this stone here. And you can see that it is reading 44 grams. So we record mass of the stone is equals to 44.00 gram. The next thing we want to do, we want to find the volume of the stone. This is an irregular object, so how can we find the volume? So we are going to pour this water and to this level. Let's leave the water to be at 300 cm cube. This does not mean it must be at 300 cm cube. It can be at any level. The water can be at any level that you can measure. But one thing you got to do here is how to stand and measure this water content. You need to avoid error due to parallax by standing to read it at the eye level. You can't read it up, you can't read it down, you have to stand and read it at the eye level. Correct. So right now, I'm reading my water content at the eye level. It is at 320 cm cube. Okay, let's leave it at that, 320 cm cube. At the eye level, the water content is at 320 cm cube. We are using from here to here, this is 300 310, and then 320. It is at the lower meniscus. Good, that is the reading. And so we'll come back to our book and write VI, that is initial volume of water, is 320.0 cm cube. So the next thing we are going to do, we are going to pick up this stone. You can see that there's a thread here, and lower it into this content. We call this displacement method. You can find this in your IGCSE. What happened here is that the water level will rise. Good. So we are going to find the new reading of the water level. Good. So you can see that the water level has risen to 300, 310, and 20, and 30, and 40, and 50, and 60. 360 is the new water level. So we record that. And so we record that the final volume of the water is 360.0 cm cube. So right now, now write that volume of the stone, Vs, is equals to Vf minus Vi. This is the same thing as 360 minus 320 and minus 320. That will give us 340.0 cm cube. And so the volume of the stone is 340.0 cm cube. So apply equation number 1. Density is equal to mass all over volume. We can now plug in the equations and find the density of this stone, of this irregular object, this stone. And that is what I am going to do right now. So the density of the stone is equal to mass of the stone divided by the volume of the stone. We substitute that mass of the stone is 44 grams. Volume of the stone is 340 cm cube. We are going to make use of our calculator right now. So 44 divided by 340, that will give us 0.1294. We'll write it to 4 decimal places. So therefore, the density of this irregular object stone is given to be 0.1294. What's the unit? Gram per cm cube. You can convert this to kilogram per meter cube. That is another unit for the density, kilogram per meter cube. So in summary, the mass of this irregular stone, ms, is going to be 44.00 grams. Help me find the units, the value in kilogram. Find the value in kilogram. And then the volume of this irregular object using displacement method is 340.00 cm cube. Help me find the value of this in meter cube. And then finally, the density of this irregular stone using displacement method is a 0.1294. 294 gram per cm cube. Also help me find the value of this in kilogram per meter cube. So this is how to find the volume and mass, volume and density of irregular objects in physics. Next up, I want to teach you how to find the density of water, this water content that you are seeing here. And when you are done doing that, help me go on Google and search. And if the result of what I'm doing here correspond to what you see on Google, come back to the comment box and give me a thumb up. Don't forget to subscribe, like, comment, and share this video to all the physics students worldwide.